Procedurally generated terrains are awesome, but this one isn't there yet. So today, we'll add multiple layers of noise to add details to the terrain, then we'll add some colliders and a player so that we can actually walk on it, and lastly, we'll apply some textures to the terrain to make it more realistic. Right now, when I want to see how the terrain looks, I first have to play the game, which is not the most time efficient, so I will create a custom editor for the terrain, so that when we change any of the variables, it will automatically update, and there will also be a button that we can press. So I will create new folder that will be editor, which I already have here, and in the editor folder I will create new C# script, and I will call it terrain generator editor. Make sure that it is really in the editor folder, otherwise it is not going to work. We'll add using Unity editor. We'll make the class derive from editor. We'll add a custom attribute to tell it which class we want to edit. So custom editor, type of, and I called the class terrain generator, just like that. Now we can add the public override void on GUI. So now the editor is still going to look the same because we are just calling the base void and haven't changed anything. But before that, we can call editor GUI dot begin change check, which is going to check if there are any changes in the variables. And then we can ask if editor GUI dot end change check, which is going to trigger when anything changes. And if something changes, we first need to get a reference for the terrain generator script, and then we want to call these voids. So I will create a reference for it. So like this, we are getting reference for the terrain generator. We are getting it from the target, and to make it easier for us in the terrain generator, instead of having to call two voids, I will create just one public void, which will then call all of the other voids that we need. So in this void generate terrain, I'm just calling the gradient to texture void and create mesh. But because in editor the update and start void is not going to get executed, we'll also need to move that into one of these voids. So in start and in update nothing is happening. It is all happening in the gradient to texture void and in create mesh void. Also make sure that the create mesh void is not again calling itself. And now in the editor script, we can just call the generate terrain void. So I will do terrain generator dot generate terrain. And you don't even have to be putting the editor script anywhere. You can just leave it in the editor folder. And now we can change any of the variables in the terrain generator. And you can set it is updating even though we are just in the scene and we are not playing the game. But there is a problem with the shader that you can see. So even when I'm changing the gradient, nothing is really changing. And this is because we need to be passing the information to the shader all the time in update. And the information that we need to be constantly sending to the shader to be working is the minimum terrain height and the gradient texture. So I will just take this part of the code and put it to the update. We also need to set the mesh variable because it is not being set in the update. So we'll do mesh is equal. We'll get the mesh filter component and we'll access the shared mesh, which is pretty much the same as the mesh. And now, to make sure that the update is running even in the edit mode, to this whole class, we can just add attribute, execute in edit mode. And now the start and even the update void are going to run in edit mode. And now we can see that the colors are working again. So I can change the gradient and it is all going to be updating even in the scene. One more thing I will add to the editor is just a button. So back in the editor script, I will add another if GUI layout dot button, then give it some text. And what is going to happen? We again want to generate the terrain. So now we can change the values and it is updating. And when I, for example, press Ctrl Z, you can see the value changes, but the terrain is not updated. We can just press the generate button. So now editing of the terrain is more user-friendly. Next, we can get to the more interesting part, which is making the terrain more detailed. so we'll add multiple layers of noise. I will go to the terrain generator script and add 3 variables. One will be for number of the octaves, which is just the layers of noise, and then variables for lacunarity and persistence, which I will later explain to you. Now, as we have these 3 variables, we will get to the part where we are using the noise to generate heights of all of the vertices, which should be somewhere here. So we are generating the vertices array. Then I am taking the value from the Berlin noise to get the Y position. But because we'll have multiple layers of noise, we'll need to go through all of them and add the values from their Berlin noises. So I will create new for loop, which will be going through all of the octaves. So from start, the Y position is 0, then I'm going through all of the octaves and we'll be adding some number to the Y position, but for each octave this number will be different. And now we can use the persistence and lacunarity variables that we have just defined. So the lacunarity is controlling the increase in frequency of octaves, which is basically just giving it more detail. So bigger the lacunarity value is, then all of the noise layers will be increasing in detail more and more, which means just greater frequency. And how are we going to do that? We'll just take the lacunarity value and we'll do the power based on the current octave. So if lacunarity is 2.5 and the current octave is 0, it will be 2.5 to power of 0, which is 1. So it will be just our basic frequency. But if we are on the octave of 2, it will be 2.5 to the power of 2, which will be something about 4. So the frequency will be a lot higher, which will add more detail. And the persistence is pretty much the same. It is controlling the decrease in amplitude of octaves. So the greater the octave is, the less effect on the overall result it will have. So if value of the persistence is 0.5, for the first octave it will be 0.5 to the power of 0, so outcome of that is 1, so it will be controlling pretty much all of the height. And then if we are on the second octave, it will be 0.5 to the power of 2, which is something about 0.2, so the amplitude will be lower and it will have less of an effect on the overall result. So in the for loop, I am going to calculate the frequency and amplitude for each of the octaves. So this is how we calculate the frequency and the amplitude for each of the octaves. We take the value, so for example the lacunarity, and we do it on the power of O, which is the current octave. And then when we are taking the value from the Berlin noise, the size we will just multiply it by the frequency, and the overall height of the noise we will just multiply it by the amplitude. And don't forget that in the for loop we are just adding the position, we are not setting it. And the way that I added the frequency and amplitude is pretty simple. This is the position, so we want to multiply it by the frequency, but it is just the x position. Then we have the z position, which we also need to multiply by the frequency, and then the result of that we can multiply by the amplitude. And after this for loop runs through all of the octaves, we can just multiply the result by the height multiplier. When we have just one octave, it looks still the same because there is just one layer of the noise, but when we set it to like 2, you can see that something is starting to change, and on 4, we can see that it is looking a lot more realistic. You can also play around with the lacunarity and persistent values, but what works for me is the lacunarity on something about 2 and the persistence on something about 0.5. So now, as we have more realistic terrain, I think it will be the best time to actually try to walk our character on the terrain. But right now there are no colliders, so it obviously wouldn't work. We'll need to add mesh collider to the terrain. We want to keep it as it is, and each time that we update the mesh, we want to make sure that we also supply the mesh to the collider. So back to our script. After we have set all of the vertices and triangles of the mesh, we'll just get the mesh collider component and set its shared mesh. And it should be simple as that. It is really important that you set it after you have set all of the vertices and triangles of the mesh and not before. So now we can just add some character controller to the terrain. I'm using the realistic FPS controller, which is for free on the asset store. So we can just take the prefab, put it here, and see if it works. And as soon as I start the game, you can see the terrain is gray. So to fix that, in start, you would just need to generate it again. But I can do that manually using the button. And yeah, you can see that I'm able to walk on the terrain. It feels pretty nice. And we can also try generating it again, but for example with a different height, and see if the collider will also update. So now it is really low. Yeah, you can see that also the collider is updated, and everything is working as it is supposed to. But one thing that is still missing to this terrain are some realistic textures, so this is the next thing that we'll do using shaders. But before we start editing our shader, we'll need somewhere to store all of the data about layers that we will have on our terrain. So I will go back to the terrain generator script and I will define new class which will be holding just a texture and the starting height for the texture. So we have a class layer holding the texture and the starting height, which is in range from 0 to 1. Now I will create a list of all of these layers. And because we'll be using textures instead of the gradient that we created last time, we can delete a lot of stuff from our script. So the terrain gradient, the gradient texture, and we can also delete the whole void gradient texture. Now our code is a bit cleaner, but I would still like to split it up into 3 parts. First will be to create the mesh, which will just add all components to the object, create the mesh, assign it, and so on. The second void will be to generate the mesh, where we will generate all of the vertices, triangles, and so on. And then the third void will be to generate the texture. None of these changes were really necessary, but I just want to make it a bit more clean. So I have added 3 variables for all of these components, and instead of adding them manually in the inspector, I'm adding them in the void create mesh. So if there is no mesh filter, I add mesh filter and set it to the variable, and so on. Then I'm creating new mesh, I'm assigning it, setting the material, all of that stuff is still the same. In the generate mesh, I am assigning all of the vertices, triangles, I'm clearing the mesh, assigning all of that stuff again. And then in the void generate texture, I'm setting the height and all of that stuff in the material, so that we no longer need to have it in update, because we are not using the gradient. I created a list containing all of the layers that we will have on our terrain, but if we want to be able to see it in the inspector, we also need to add the system.serializable attribute to the class. Just like that. Now when we go to Unity, we can add as many layers as we want and set their starting heights. Now we can go to our terrain shader, where we'll need to define 3 variables. One will be for the current number of textures that we are using, second one will be the array of all of the textures, and third one will be array of floats, which are just going to be containing heights of these different layers. But we need to specify size of the array, and we can't do it dynamically, that we would have another variable for number of the textures and just assign it to the size of this array. We need to have a predefined value of how big the array will be. So we can, for example, input just 256 and use only the slots in the array that we need. And to make it more convenient for us, I will just define the number. So I defined max textures to 32, which will be enough for now. Next, we can define the texture array, so you might be thinking that you can just do sampler 2D, then give it some name and then the square brackets, but this is not possible. We need to instead say Unity declare text to the array and then to the parentheses give it some name, so I will just call it terrain textures. So like this we declare the texture to the array and we don't even need to specify its size. And lastly, I will define integer for number of the textures that we are currently using. Now we can set all of these variables through our C# script. So you'll go to terrain generator and we'll be doing that stuff in the void generate texture. So we are setting the integer layers count just like that, pretty simple. Next we will set all of the heights, so I will need to go through all of the terrain layers, get the heights, create an array with them, and then send it to the shader. I'm creating float array. The size of this array is just the total count of all of the layers. Then we have some index, and in the for each loop I'm going through all of the layers in the terrain layers, and I'm assigning value to height on the correct index to the start height from the current layer. And then we can just set the float array in the material. Then we will need to set array of all of these textures. You might be thinking that we'll just create array of textures, but here it is like just one texture. Because when you type material dot and you would want to set texture, you see that there is just set texture. There is no set texture array. So this is why we have to do it a bit differently. We will need to create texture to the array. Then we will specify width and height of each of these textures. I think that 512 will be enough. Then the depth, which is the amount of textures that we'll have here, which is the same as the layers, so layers count. Then we need a texture format, which is basically the color format. I am not an expert in this, but I will use the RGBA32, just like that. And the last parameter, if we want to create mip maps, we want, because it looks better with them. Like this, we have created the texture array, and then we will need to go through all of the terrain layers and set the textures to the array. Just one thing that I forgot in the layer class is that it should be texture 2D, not just classic texture. So we are going through all of the layers, and here you can't just set the layer to the layer array, you have to set all of the pixels. So we are going through all of the layers. I'm doing textures.set pixels. Then we first need to input the pixels, so we can just take it from the correct texture in the layer. So we are doing terrain layers on the index of I. From this we access the texture, and from the texture we get all of the pixels, which we then supply to the texture array. And the last parameter is just the index in the array where we want to store it. So this is again I. Don't forget to then apply the texture, and we can set it to the material. So we are applying the textures, and then, as I said, we are not using set texture array, because this is not even an option. We are just setting texture, then the name, which is in the parentheses here, and to which value it is the textures. So now hopefully all of these variables will be correctly passed to the shader, and there is one more thing that we need to change on all of these textures that we want to be using. So I will go back to Unity and go to the folder where you have all of your textures. I have downloaded the Unity terrain sample assets. So in the folder textures, and I'm using the terrain ones. So we want to select all of them that we want to be using, and it is important to set their size, maximum size, to the size that you have specified in the script. So I have specified 512, so set it to that. And also you need to enable read and write, which is by default unticked. And then also don't forget to apply the changes. And now we can get back to shader coding. From the shader we can delete the gradient, and we can also delete this line where we are setting the albedo. So first we'll need to go through all of the layers, and we'll just ask if the current height value is greater than the current layer that you are checking, and also if the height value is less than the next layer that we will be checking. So from start I'm setting the correct layer index to -1, then I'm going through all of the textures, but not the last one. This is because then I'm checking if the height value is greater than the height on the index of I, and at the same time the height value is less than the terrain height on the next index. So this is why there has to be the num textures -1, because here we are getting the I +1. And if this is correct, it means that we are on the correct layer, so we can set the layer index to I and break from the loop. But what if we don't find any correct layer so that the layer index is -1? This just means that we are on the top layer. So we can just check if layer index is -1. If this is true, we will set the layer index to the maximum layer. And now, as we have the correct layer index, we can just sample the texture on the correct index. We are setting the albedo. Normally, if you want to sample the texture, you would do just text to D, but here, because it is the texture to the array, we have to do it like this. It is pretty much the same. We first input the array from which we want to take it. Then, instead of float 2, we are importing float 3, because the third element of this float is the index from which we want to take it, and the first two elements are obviously UVs. Here is just one small mistake. When defining something, you don't even type semicolon at the end. We are getting another error, which is telling us that some variables have not been assigned. This is because in the part where we are just creating the mesh, if these components are not null, we are not assigning them again, so we can just get the components and assign them to the variables. So we are assigning the mesh filter, render, and collider. Now it is still not displaying the texture correctly, because it is probably not scaled correctly. So back in the shader, I will create float variable for the texture scale. So we have a property for it. Now also create a variable. And we are not gonna be using the UVs. Instead, we will use the world position. And in the surface shader, we will just calculate the scaled position. So take the world position and divide it by the texture scale. And now we can take the scaled world position and input it instead of the UV. And from it, we want to take the X and Z coordinates to make sure that the texture is being applied from the top. Just like that. And now we can finally see that some texture is being applied, but when we are changing heights of these textures, nothing is really changing and we are only able to see the top layer, which is because in the terrain generator, when we are setting the heights, so we are going through all of the terrain layers, I obviously forgot to add the index after we go through the for each loop, just like that. And now we can see that the tops are green and the bottoms are kind of gray, which is because I set the textures this way. So I can change this and everything is updating. I can even add third texture, which could be some kind of snow. And like this, I think you can create some decent looking terrains. There is still definitely something missing, such as the blending between the layers. But right now you can add as many layers as you want and set their starting heights and all of that stuff. One more thing that I had to change in the generate terrain script was to remove the execute in edit mode, but we really no longer need that, so we can just delete it. So now you know how to make your own procedurally generated terrains for your games. It is definitely not the best looking terrain, but I think it is a decent start for any game. Let me know if you want to see more videos on this channel about procedural generation. Next time we could make some blending between those layers and add some other interesting stuff. Also, if you are interested in making 3D water shader like this one, then feel free to check my latest video. I hope that this video was useful. If you have any other tutorials that you would want me to make, then feel free to tell me down in the comments. Don't forget to like, subscribe, and I will see you in next videos. Bye! Thanks for watching this video till the end. If you are looking for a Unity, C# or Bolt tutor, then I am here for you, so feel free to send me a message to my Gmail and take a look at my website for more info. I can help you with your personal projects or teach you anything about game development you would want to know. You are welcome.